In this video, I'm going over our lesson that continues focusing on quadrilaterals and the diagonal relationships, but now on the coordinate grid. So again, going back to this grid and table here that we talked about in our previous lesson, and remembering that the parallelogram does not have the congruent or perpendicular. Neither does the rhombus. So rhombus and parallelogram, the diagonals are not perpendicular. But notice in the rhombus, the diagonals they're not congruent. But the rhombus, the diagonals are perpendicular. Then here in the rectangle and square, the diagonals are congruent to each other, but in the square, the diagonals are perpendicular. So again, going back to that relationship. So now when we're looking at the quadrilaterals, but now on the coordinate grid. So like, for example, we know for a fact that for all of them, no matter what, if we have a special type of quadrilateral, so if we have a parallelogram, rhombus, rectangle, or square, that you should always have diagonals that bisect each other, which shows that they're bisecting each other, they're cutting each other into two congruent pieces, which means that they are here in the middle, crossing in the middle, hence using midpoint formula. So if you end up with a quadrilateral that does not cross, and they do not have a midpoint that is the same where they're crossing each other, then you do not have any of these four, because no matter what, in all four of them, they must bisect. So then moving forward and building on that, if you have the rectangle, of course, still we have the bisecting, but now keep in mind that they are also congruent to each other. So if the diagonals are congruent to each other, like BD is equal to AC, then how are we going to find that the lengths are the same? Using the distance formula or Pythagorean theorem. A squared plus B squared is equal to C squared. So then the rhombus. Now remember again, the rhombus, no matter what, bisecting each other. So of course, midpoint is there, but now they are not congruent. So again, we don't have to show that they're congruent, but we now have perpendicular, which means how are we going to show that perpendicular? The slope. So again, keeping in mind that the slopes have to be that negative or opposite sign and reciprocal relationship. So we are again looking for that slope with the diagonals. So then our square, there's two things to keep in mind on top of that midpoint because they are still bisecting. They are also perpendicular, the diagonals are perpendicular, so we have that slope relationship, and they're also equal to each other. The diagonals are congruent, hence using distance formula. So a squared or a squared plus b squared is equal to c squared, Pythagorean theorem. So looking at example 1, we're going to determine what type of parallelogram this is, but using the diagonals. So we are focusing on diagonal AC. So let's look at AC, but let's identify the points. So AC is at 0, 10. And C is at -2, -1. Now I'm identifying the points. So here now I could go into distance formula or another option. Remember, you can use and create the right triangle because you'll need it for slope and distance as well. So here we have a rise of 11 and a run of 2. So that means here we have a slope of positive 11 over 2. Then here for those, if you decided to do distance formula, you'll see that everything matches. So here with Pythagorean theorem, we've got 2 squared plus 11 squared is equal to our c squared. Then same thing here for those who did distance. you have 0 minus negative 2 squared, which gives you 2 squared, plus 10 minus negative 1 squared. Notice 10 gives you 11. So again, whatever method you're practicing using, make sure that you will still get that same answer, especially with those distances when you're looking for slope here. So as we continue, we have 4 plus 121, which is equal to 125. But again, no matter what, we always then take the square root. So we have a distance of radical 125. So now let's go to BD. So BD, again, we can identify the points, making sure you're on the right track with if you want to use distance. So B is at 4, 2, and D is at negative 6, 7. Or again, if you just want to use Pythagorean theorem, because you're going to need it anyways too for the slope, our rise and our run. So the rise is 5. So 1, 2, 3, 4, 5. And then the run is 10. So here that means the slope, positive or negative, well now reading it left to right, the slope is negative. Then rise is 5, run is 10. So negative 5 over 10, which simplifies to negative 1/2. So that is our slope here. Now let's continue finding distance. So I'll go ahead and stick with the Pythagorean theorem. So here we've got 10 squared plus 5 squared. So if you decide to practice distance, you should have done 4 minus negative 6, which does give you 10 squared, which will be 100, plus 2 minus 7 is negative 5, but negative 5 squared is the same as 5 squared, which is positive 25. And then we're going to go through and continue solving. So now here again, 125, but then always last step, take the square root. So our distance is radical 125. So now looking at the two diagonals, notice how we have distances are the same. So they are congruent to each other, the diagonals. But do we have negative reciprocal slope? No. So they are not perpendicular. They're only congruent, which means we have a rectangle. Because they are congruent to each other, but they do not create a 90-degree angle, the two diagonals. Let's do the next example. Here again, focusing on the diagonals, so focusing on AC. Point A is at negative 3, 5, and C is at 2, 2. So again, I will focus on, because I've noticed a lot of people in class too, they focus on creating that right triangle, like your slope, rise, and run, because then you also use that for Pythagorean theorem. So here the rise is 3 and the run is 5. So here the slope, reading it left to right, is negative 3 over 5, rise over run. So now here to get the distance, we have 5 squared plus 3 squared is equal to c squared and solving. So here you end up with 25 plus 9, which gives you 34, but then of course take the square root. So the distance is radical 34. So go ahead now and pause the video and do the slope and distance of BD on your own. Just try BD. And here we go. So again, I'm going to focus on creating rise and run. So I notice that my rise here, or slope, is positive My rise is 5. My run is 3. So we have a slope of 5 over 3. And then again, 5 squared plus 3 squared is equal to c squared. You should have noticed that the radical 34 ends up giving, because we already solved 5 squared plus 3 squared. So again, the diagonals are congruent to each other because the diagonals are the same length. You should have also noticed the slope. Well, what do you notice? Negative reciprocal, which means the diagonals are perpendicular to each other as well. So is this a square or is this a rhombus? This is a square because we have congruent diagonals and the diagonals are perpendicular, creating that negative reciprocal. So we have a square. So go ahead and pause the video now and try the 2 U-tries, again, focusing on the diagonals on your own. And here we go. So again, focusing on the diagonals, so diagonal RT. I'm going to go right into creating my right triangle to get my rise and run for my slope. Now, notice here, we're going down, so negative slope. Your rise is 4 with a run of 4. So here you have negative 4 over 4, which gives you a slope of negative 1. Then here, same with you sides to use to find the distance. So 4 squared plus 4 squared is equal to c squared. So here you should have gotten 16 plus 16, which gives you 32, but in the end, radical 32. So the distance is radical 32. So then here now to find SQ. Here, notice that the slope is positive, then creating my rise and my run. My rise here is 2 with a run of 6. So my rise is 2 and then over 6, which is positive 1/3. And that means here, same thing, we're going to use those side lengths to find the length of QS. 6 squared plus 2 squared is equal to c squared. 36 plus 4, which is equal to 40, is equal to c squared. But then, of course, take the square root. So the distance was radical 40. So now notice we have diagonals that are not congruent to each other, and the slopes are just different. They are not creating a perpendicular 90-degree angle. So that means we have a parallelogram, not a rectangle. Then in the U try here, again, focusing on here, e.g., notice that the slope is negative, then rise over run. The rise is 1 with a run of 5. So negative 1 over 5. Then here, using those side lengths to find the distance, 5 squared plus 1 squared is equal to c squared, or 25 plus 1, which gives you 26. Then, of course, take the square root. So the distance is radical 26. Then going on to the other diagonal here, FH. So again, getting that slope, notice how reading it left to right now is positive. And then the rise is 7 with a run of 1. So positive 7 over 1 or just 7. Then again, using to find the distance, 7 squared plus 1 squared is equal to c squared, or 49 plus 1, which gives you 50. Then of course, take the square root, and you should have gotten radical 50 as the distance. So again, these diagonals are not congruent and the slopes are not that special characteristic. So again, you have another parallelogram. So go ahead now and pause the video and answer parts A, B, and C for this problem on your own. So this last question was open to however you wanted to solve this problem. So depending on how people could have solved this, whether using the focusing on the sides like what we have done in the past, or focusing on the diagonals. So I'll do the sides first so that we can see here. So the side, so like let's say Diego to Ramon or DR here. So dr, I have rise of 2 and run of 6. So that means here your slope is positive 2 over 6, which is 1/3. Then the distance is 2 squared plus 6 squared is equal to c squared. So here by solving, you have 4 plus 36, which is 40. You end up with radical 40 as the distance of dr. Now here, this is just a vertical line, so you could just count that and say that the distance between Sam and Ramon is 4. Then here, Kyle to Sam, so KS. So again, creating that right triangle, I have a positive slope, rise of 2, run of 6. So again, 2 over 6, which is a slope of 1/3. Then again, notice same sides, 2 squared plus 6 squared is equal to c squared, which gives you radical 40. Then here, if you were to count Diego to Kyle, you also have 4. So just from the sides, do we have a parallelogram? Yes, because the opposite sides are congruent and parallel to each other. So we do have a parallelogram, that special type. Now, for those who did the diagonals, to make sure that you did that correctly. So here I have DS. So DS has a negative slope, the diagonal. Then here I've got a rise of 2 and run of 1, 2, 3, 4, 5, 6. So again, now the slope is negative 2 over 6 of that diagonal, which is negative 1/3. Then notice here, you also ended up solving 2 squared plus 6 squared, which is equal to c squared. So from previous, we already know that this is radical 40. Now let me erase this other work. Sorry about that. So we can see this here. Then here, going to the other diagonal. So Kyle and Ramon. So I'll label that KR. Now notice this slope is positive, then getting our rise and run, you end up with a rise of 6 and a run of 1, 2, 3, 4, 5, 6. So this is positive 6 over 6, which is 1. Then here now you ended up solving the distance, which was 6 squared plus 6 squared, which is equal to c squared, or 36 plus 36, which after taking the square root, you should have gotten radical 72. So does this also show that you have a parallelogram? Yes, because the diagonals are not congruent to each other and they are not intersecting at a 90-degree angle, showing a perpendicular relationship. So you could have gone either way to show that you have a parallelogram here. Now, using all of this information from the previous to determine if the quadrilateral is a rectangle, a rhombus, or neither. Well, a rectangle, you have to have congruent diagonals. So do we have congruent diagonals? No. A rhombus, the diagonals are different, but they also have to show a 90-degree angle. Do we have that negative reciprocal here? No. So that's why this is a neither. So going back to the concepts of the diagonals. diagonals. So this is strictly just a parallelogram. Then the last problem, let me go back and redraw, was asking that if Ronald's house that they were claiming is the same distance to Kyle's house at the intersection of the diagonals, which means if it's the same distance from all four friends' houses, then what are we asking for? What did you have to use? Midpoint. So here, if the diagonals, going back here, if the diagonals are crossing at the midpoint, then that means that Ronald's house is the same distance from all four because the diagonals have been bisected. So for this problem, you needed to set up midpoint formula. So again, we're going to go back to DS, but now identify the points to use midpoint formula. So D is at -3, 3, and S is at 3, 1. So now using distance formula, you have -3 plus 3 divided by 2, and then the y's. 3 plus 1 divided by 2. So notice here you have 0 divided by 2, which is 0, and 4 divided by 2, which is 2. So that is the midpoint of the first diagonal. So now let's do Kyle and Ramon. So KR. So K is at -3, -1, and R is at 3, 5. So here, finding midpoint, -3 plus 3, right? Your two x's divided by 2, and adding the two y's, -1 plus 5 divided by 2. So here you have 0. Here, let me just scroll down. There we go. Here, here you end up with 0. Here you end up with 0 divided by 2, which is 0, and 4 divided by 2, which is 2. So notice how two diagonals have the same midpoint of 0, 2. So that is where Ronald's house would be located, to be the same distance from all four friends' houses.